Okay, let's get started. Good afternoon. Today's topic is GoodWe utility scale solar plant solution. And there will be a lottery section after the webinar. We will draw 5 audience from the background, and the prize is a $20 Amazon gift card. The winner will receive a personal notification email from the community. And let's get started. There will be 2 parts for my presentation today. And the first part is the construction of utility scale PV plants. The second part is GoodWe solution for utility scale plants. Let's get into the first part, the construction of utility scale PV plants. Here we have a pie chart of the construction fee, construction cost of PV plants. As we can see, the most part of it is the PV module. It will cost 48%. Okay, it will cost 48% of the construction cost. And following is a 12% cost of installation, and then the PV module bracket, and then 6% of serial lighting, heating, ventilation, and so on. So after that, there are some small parts of the costs. For example, the booster station, allowance, cable, inverter, power station, weather station, and design. Obviously, in this chart, we can see that PV module is a really big part of the cost, and it's also important. But we cannot just speculate the importance of it by the cost of them. For instance, the least part in this pie chart is design, but it is a really important part. A good design can save a lot of money and also save the work afterwards. And a good design could even make more money by reaching a better system efficiency. And this slide shows the process of building a utility scale PV plant. It includes designing, equipment selection, installation, and the O&M after the plant starts to operate. In the design process, it needs a comprehensive construction of the whole system. For example, the method of bracket installation, load problem, electrical system, the arrangement of PV modules. And the second is equipment selection. We have to select safe and reliable operation equipment. So we can choose products with better performance, which is stable and reliable. And those who have fully protections is also a priority factor. We have to consider it. But the price is also a really important one. We have to consider the cost, obviously. And then it's the installation process. So this one, we have to control the process, control the quality of the installation. We have to consider professional construction, and we need sufficient tools, and we have these installation standards. By following these standards, we can reduce further risk of the system. And the last one is the O&M. It's not only in the construction process, it's a lifetime work. Once the plant is working, is operating, we need this very much, and we need this timely and accurately. Once the plant is transferred to O&M personnel, they have to be fully trained, and they have to respond quickly. They can accurately locate the faults in the PV area, and then they can prevent accidents from expanding. So by doing all these jobs above, they can guarantee power generation income. Here shows some necessary steps to construct a PV plant, which is a big PV plant. So the first step is a material approach test. Once the equipment approached, well, we have to do the end packaging and the inspection, visual inspection. So according to the drawings, we have to unload the material distributes in each PV array. That can prevent second hoisting. We can just put them in the right place at the very first time. And then we have to take care of some key points of hoisting, and the people involving in this process, of course, they have to sign this. They have to make sure all the materials are right, the number of the materials are right. And the second step is the civil construction. For the civil construction, they have bracket base, electrical equipment foundations. So it's for example, it has concrete pouring, and then we have to wait curing after the strength reach 70%. Then we can start the install the bracket. So the bracket and the embedded parts installation is the next step. The verticality and the levelness of the support installation affects the quality of the entire array. The larger installation deviation of the bracket can cause the model to crack under the force and the bracket to damage under the wind and the snow load. And after that is the electrical equipment installation, including the inverter, transformer, and other equipment, electrical equipment. After that is the AC and DC cabling, lightning protection, and grounding. And after that is the commissioning on primary and secondary equipment. So this is our view of this construction, and shows a few stages of the construction. As we can see, we have the location, the first time, the first part, the first period, we have to find the place to install this PV plant. And the second stage is the design stage, and then to select the correct equipment, and then the construction. So these 4 stages is the main investment period, and it will take about 0.5 years. And the last stage is the O&M stage. So this is not only in the construction, it's during the operation of the PV plant. So this is the main payback period, and it took about 24.5 years, and that's 98% of the lifetime of this PV plant. So this part is also really important, the O&M. And here we go to the second part of today's presentation, this GoodWe solution for utility scale plants. And let's see the system overview. This is a utility scale PV plant system. We have the modules, and then DC cables connecting to the inverters. The inverters are connecting to an ME station, and then a booster station, and then it can connect to the grid. The SCB3000 here is a communication box, solar communication box, and it can collect all the informations from the PV array, and then it can upload it from to the switch. Then the PPC, SCADA, and other systems can get all the informations, all the data. So here's our inverter, the HG series 250K inverters. It has 6 MPPTs or 12 MPPTs, depends on different model. And the current is either 15 ampere or 20 ampere, and that will be the main difference between these two modules. We have a high efficiency, and we have a bunch of protections on this inverter. So here is the difference between GoodWe 250K and 250KN. So the KN, it has 6 MPPTs and 3 strings per MPPT. That's 18 strings per inverter. And since it has more than 2 strings per MPPT, so it has a smart DC switch on it. It looks like this. And we can see for this is compatible for 2 10mm modules. Here listed are some examples. And so it has a maximum input current of 20 ampere. For the GoodWe 250K, we have a normal 12 MPPTs and 2 strings per MPPT, and the maximum input current is 15 ampere. So the inverter in the PV system is the key point of the whole system. It converts the DC power to the AC power. So and it also do all the communication work. It collects all the information. So this although it's not a big part of cost in the construction of a PV plant, but it is a really important device. And the next thing is the PID effect. So in these pictures, we can see from left to right is the process of PID, but PID can be prevented and also can be recovered. So our inverter have the PID solutions, have two. The first one is we can do the anti-PID during day. As we can see on the DC side, between PV positive and PV negative is UDC, and we divide it into, we find the neutral point of it, and it's 1/2 UDC for each. And we also find the neutral point of the AC set as well. We have this neutral point device and then voltage adjustment device, and that adjusts the voltage between this neutral point and the ground is bigger than 6 volts plus 1/2 UDC. And this neutral point and this one are neutral. They are keeping the same stage, and that's how it makes the PV negative. And the ground is also bigger than 6 volts. And this is the second solution for our inverter, which is the PID recovery. It basically has this internal PID repair board, and it can give a reverse voltage for 600 or 700 volts between the PV negative and the ground. And this we also have this MV stations here. This is how it looks like. It can cover 7,000 kVA, and the highest voltage level is 40.5 kV. We can do double slit transformer or double winding transformer. And it fits in a standard 20-feet container, so the installation would be really quick. Just LV and MV cable will be used on site. The LV room and MV room is IP45, and the transformer is designed for outdoor use. Here is a single line diagram of this system. We can see the inverters are connecting to the LV switchgear, which including this is a double speed transformer, so it includes 28 MCCBs, and then goes to the transformer, and then goes to this MV switchgear. It connects from, it has this CVC RMU, and it's connect to the previous MV station and collect the current from this one and goes to the next PV array. We also have a communication solution for the inverters. So the inverters with PLC 2.0 communication function can be support for power line communication by AC wires. That means that we can save a lot of communication cables by this. And the SCP-3000 will do the main work of the PLC communication. And the basic principle here is to, as we all know, the frequency of the power, the AC power, is normally either 50 hertz or 60 hertz. It uses a much higher frequency to communicate, to transform the data, the information here. And this is our smart solar communication box. So it collects all the information from the inverter, also the MV station, the weather station, the tracker, and so on. So it collects all the data from the PV area. And it has this ring connect, and the yellow line here is the optical fiber. And one of this is going to be the master one, and it will connect through LAN or fiber. This is depends on the distance between them, between the SCADA system, between the switch. And by this ring connect, it has these advantages because once there are one point in this ring are disconnected, the communication of the system won't fail, and the communicator will they just go to another direction. So this line here it will be in hot spare normally, and once this point break down and is disconnected, and it will automatically change to this direction and use this wire. Other than that, we also have this local SCADA system. It's located on site and shows all the data of the plant. So this Solar OS system, it can do the control of the monitoring and control of your plant. In this slide shows all the functions, all the menu of the Solar OS system. We can see we can do some intelligence analysis, for example, the equivalent operation hours, and we diagnosis, equipment management, system management, and others. It has a really great alarm management system. It shows all the alarms and basic settings. You can set your alarms. You can set the level of the alarm, and it has this floating box just for the alarm. So whenever the page you are in the system, the alarm will always on the screen, and you can find the alarms directly. And I think that's all for my presentation. Do you have any questions? You can ask them in the Q&A box. Okay, here I got. No questions yet. Oh, here, I found the question here. It says, what should we pay attention to in PV plants on mountains? Yes, sure. We have some plants are located on the mountains, and for this special landscape, we have some point to take care of. We have to pay attention to. The first thing is we should consider the altitude, and usually in mountains landscapes, they have they usually have a high altitude, and the performance of the electrical devices when the altitude is high, it's unstable. We cannot say it. So we have to consider whether it's going to be derating at this level of altitude. So we have to consider the local condition, the altitude. For example, the altitude is 3,000 meters and 4,000 meters. So we have to find some devices which are not derating during this altitude. And if it's too high, like over 5,000 meters, so we cannot find any devices that they're not derating anymore. Then we have to consider this factor during the design stage. And the second point is the PV modules in such PV plants tend to face in different directions. The mountain is not like a flat field. So the PV modules are facing different directions. And to reach a higher efficiency, those PV panels which are facing the same direction should connect to the same MPPT of the inverter. And that makes the MPPT track the maximum power point when the PV module connect to it. And since they are connecting to the same MPPT, they are working under the same condition, and the MPPT will have a higher efficiency, and you will get more power generated. So that's the answer for the first question here. And the second one is when using PID solution, day solution, do we need to use special AC cables, or we can use traditional cables? For our product, you can just use traditional the cables you use as usual, because all these are internal board in our internal boards in our inverters. So it's all integrated in the inverter. We do not have any other external devices and other different equipment. So the cable will stay the same. And I noticed there are more questions here. As what is the main difference of string inverters and central inverters? So between string inverters and central inverters, the string inverters have more MPPTs, so that makes it has a higher efficiency. It's also easier to O&M. Although the central inverter costs less initially, but with the higher efficiency, string inverters will have more power generated and will pay back the initial investment. Yes, the KN series is equipped with the smart DC switches. So that is protect from the current overload, and it will just disconnect once the current is not right. So that's well, but why for it is because for the K series there are only 2 strings per MPPT, and the KN series it has three strings. So we normally we use a fuzz here, and it's hard to O&M for this fuzz. So we have this smart DC switches, and we can just to reset it after we see 10 times it opened and closed. So that's either. And I see there's more says what more should we take care of when PV plant is near the sea? Normally, how do you define where the PV plant is near the sea? So corrosion is one thing to be considered. All the devices used in this kind of PV plants should have considered this issue, including inverters, transformers, and so on. And GoodWe inverters can reach a C5 level anti-corrosion. And I think wind is another thing to be considered. We have to reinforce the bracket. The cables on site should also be covered by the PVC tubes, let's say, or other, of course, tubes made in other materials will works too. And the how do you define the near the sea? So normally, once this PV plant is built in near sea city, and that's we will see near the sea. So it's, let's say, maybe 40 kilometers, 50 kilometers. Since the wind from the sea is blowing over here, so that's we have the salt inside the wind. So we have to consider as PV plants near the sea, and we have to consider the wind, the strength of the system, and then the corrosion. The next one is, have you received any certificate and approval for the adoption of this solution as a replacement to PV fuses from the PV modules, PV module makers, and from international certification institutes like GoodWe or others in regards to related standards? I'm not sure about this yet. I have to check this. And if we have this certs, I think it's not from the PV module makers. It's have to from the some certification institutes. Please wait just one moment. I'm checking with them. Yes, we have for the smart DC switches. We have the certification from GoodWe and CE. Floating. What is GoodWe's solution for utility scale floating PV systems? Floating PV systems is not much more different from flat field. The most difference may be for the PV bracket, PV support, and that's it. For the inverter side, I think it's no more different since we have this C5 level of anti-corrosion. I think that's the same. And we have done some project for the floating PV system already. I have already answered that. Okay, do we have more questions? Okay, here. Huh? Can't see this. How can we get a software from GoodWe Tech if we have fault errors encountered on inverters? Sorry, I didn't understand that really well. How can we get a software from GoodWe Tech if you have fault errors? Oh, you mean the software to update the inverters? So this is maybe it's an after sales questions problem. You can call the after sales number, or for the firmware upgrade. Yes, you can call them. Or for me personally, I know that you can upgrade it by insert the USB, and that's sometimes that works with the upgraded files in your USB drive. So if you have any problems updating the software, you can just call the after sales, and the after sale team, they will help you with your issue. Could you please tell me your largest GoodWe inverter solution for utility scale power plants? For now, our largest inverter is 250 kilowatt. We have two series, which is 250K or 250KN. And the KN is specialized for 210 millimeter PV modules. It can support more than, it can support a maximum value of 20 amperes. And for the 250K, it can support 15 amperes, which covers most of the 180 millimeters. PV modules. Okay, good. Do we have more questions here? Oh, I think I had one more. Yes. No, that's the same one. Here, how many inverters can be connected to SCP-3000? For SCP-3000 is our solar communication box, and we can connect a maximum number of 60 inverters per SCP-3000 per communication box. And in most cases here, it's since you have if you use if you use PLC communicating if you use PLC communicating and you use this SCP-3000, and the number of the inverters is not only depends on the communication box, it's also depending how many inverters are you going to connect parallelly to the transformer. So in most cases, the number is 14, 13, 10, or something like this, because the MV station, the transformer is maybe 7,000 kVA or sometimes 3,500 kVA, and since it's communicated by AC cables, so even though you use this double split transformer and you have double split transformer and you have I think a maximum of 28 inverters, and in the real cases, 28 may be the most you can connect. But theoretically, you can connect up to 60 inverters. The IV curve diagnosis function is free or need to pay. I'm not sure about this yet because we are not releasing it right now, but near the future, maybe a few months, and this function will be released. And this one will be charged. But if you have orders now and if you want to try this, maybe it's not settled yet. And this function is not totally out yet. If once they're out, you can ask for the price. So I'm not sure about the precisely price of it, how much. I'm not sure, but it will be you have to pay afterwards. Maybe once this function is released. What are the latest hybrid inverters that GoodWe have? Sorry, I'm not really familiar with the hybrid inverters, and I have to check this afterwards, and I will give you the feedback through email. Okay, I see here one more question. Are there any temperature requirements for the inverter, the SCP-3000 and the MV station? Yes, there are some temperature requirements, and for the inverter, the temperature is -40 degrees C to 60 degrees C. Yes, and it will derating from 50 degrees C. Yes, that means that you will get full capacity, full power, even though the temperature is 50. And here, do you provide Turkey ESS solution? Sorry, not yet. We don't have that yet. I would like to know if GoodWe storage inverters can be used with DIY batteries. I think the answer of this one is no. We have certain brands that we're already compatible with. we have to do some configuration on our side as well to be compatible with all the batteries. So we're not compatible with all the batteries on the market yet. So for the DIY batteries, I think it won't be okay to use with. Your utility scale solution can set up to 110, 110 kV. Yes, so in the system, you can see after the inverter, it goes to this MV station, which is a small transformer, and then after that is the booster station, and then it connects to the grid. So the point, the voltage level you want to connect to the grid, you can depends on this booster station. For example, if you want to connect to the grid at 110 kV, and then you can set your transformer, your MV station as 800 volts to, for example, 30.5 or 35 kV, depending on different regions. And then after that, you use your booster station, and it can transform the voltage level from 35 kV to 110 kV, and then the connect point to the grid, the voltage will be 110 kV. Do we get parameter or from SCP-3000 or inverter for prediction remaining useful life? Not yet. We don't have this useful life prediction function yet. Do we monitor what was the curtailment power? We if you want to set a limit of the output power of the inverter, you can, and you can control it. You can monitor it as well, of course. Okay, do we have more questions? So we use SolarOS to do the monitoring. Can we use third-party platform? Yes, of course. It will be compatible with third-party platforms, for either PPC or SCADA, and it can get all the data from the switch. And SCP-3000, the communication box, will deliver all the data, all the information up to the switch from the PV area. And the SolarOS do the monitoring. Yes, we can use the SolarOS to do the monitoring. We can monitoring the administration, the inverters, the tracker, and the weather station, and also other than the monitoring, we also can do the controlling. For example, we can set the active power, set the reactive power of the inverters. We can control the inverters from the power factor and so on. And we can disconnect it, close it, all kind of controlling stuff. And we can also do the upgrade through this platform. If the software upgrades you need to do for the inverters, you can upload the update file into the system, and you can select all the inverters in your plants, power plants, or you can select part of them, and you can upgrade the inverters just by one click. All the inverters. Please describe the unique feature of your string inverter 250K compared to existing string inverter. So for our string inverter 250K, it has a higher rated power. So that means it has a higher power density, of course. And it has a lot of protections. For example, the DC reverse protection, the DC overload protection, over voltage protection, and anti-islanding protection, FCI, and so on. So it's really reliable. It's safe to use, at least. And the 250K series, the string inverter, is really the performance is really good, and the fail rate, the failure rate is really low from now. We can see from the existing data we have now, from all the inverters are using on site in real project, and the failure rate is really low. Okay, for today's webinar, I think this is the end. If you have more questions, you can just send it here, and I will give you the answer back later through email. Okay, here's the last one. Can we have another webinar for technical training on GoodWe inverters? We use GoodWe in our solar roof PV plants. Technical training for so that's the residential solution maybe, and we might have able to arrange it later. I will send this message to our team, and I will ask them if we can arrange this webinar for a residential solution for the technical training. Okay, of course. And I think that's the end of today's session. And if you have more questions, you can just leave a message. And after this webinar, we will draw 5 audience from the background, and the prize is $20 Amazon gift cards. And the winner will receive a personal notification email from the community. And that's all. Thank you all very much for today, and goodbye. Have a nice one.